Hello everyone, another week of building wireless sensor networks. This week we're doing Chapter 7, Over the Borders. And here let me describe the hardware setup. We have our Arduino, and attached to it is a LCD screen. The LCD screen is getting serial information displayed of a Twitter feed that we will go out and fetch over the internet. The Arduino will send a serial command to the Zigbee. The Zigbee will then communicate with our connect port X2, which contains a Ethernet bridge and another Zigbee. So I put them on the same network. I installed the XIG Python script on the connect port, and so when the Arduino says HTTP something something something, sends it to the Zigbee will communicate with the connect port. The connect port will go out to the internet and fetch that URL, no matter what is at that URL. In this case, I have wired it to Lady Ada's, Adafruit's Twitter feed. So let me reset this guy and we can watch it start from scratch. Loading. When it loads, the serial communication light lights. And we got a Twitter feed. The Adafruit Twitter feed. Live stream from Hardware Innovation Workshop and a URL. What is really interesting about this project is that it allows the Arduino to bridge the gap, the wireless gap, through a Zigbee. And the secret's through the connect port, because the connect port contains a corresponding Zigbee coordinator. And then that bridges, of course, to the internet. Going out and fetching any URL on the internet is a pretty interesting thing, because it more or less allows you to mailbox things on the internet and then have the Zigbee, your internal Zigbee network, go out and fetch them. So you save a mailbox message, and then when the Zigbee wakes up, or when you want to go out and fetch it, you go and fetch it. Here in a minute or two, I will show a demo where I set up a website with a little PHP script, and I will go out and type in a message and have it displayed on the LCD, because the Zigbee will go out and fetch the URL. So here we are at part 2. The XIG Python script loaded onto the connect port allows the Arduino to say, go fetch a URL, and it will return whatever is at that URL, no matter what it is. For example, if you go to CNN.com, it will return like HTML tags. Of course, the Arduino isn't a browser, so it will simply return whatever was there. JavaScript, HTML, whatever. For this demo, I have written a very rudimentary website that has a submit page. When I enter a message, and I'll do that right now, Frank Burns eats worms, it will mailbox that message, and when the Arduino will periodically go out and fetch that message, and it will display it on the screen. I set my timeout to 15 seconds, so this should, we have to give it a little time. Here we are. Give it a little time for it to go out and fetch it. Frank Burns eats worms. Yes, I've heard that. Let's see here. Flash Gordon is... actually, we'll do saved. Every one of us. There we go. Oh. Success. The message, blah, 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 was placed in the mailbox. Behind this website is an SQL database, and whatever message I type into that box is stored there. When the Arduino periodically goes to fetch that URL, there's a separate URL that I place. It will display that simple message through a PHP script, which allows you to have a very powerful tool. You could write a text parser for the Arduino you could mailbox commands, and the Arduino will periodically go out, fetch that URL, and execute those commands. Makes it a very powerful tool. Thank you for watching, everyone. Appreciate it.